The National Electrical Code, or NEC, establishes minimum requirements for electrical installations to ensure safety. When installing a 1200 amp main service underground using 500 MCM copper conductors in PVC conduit, several factors must be considered to comply with the NEC. These include conduit fill, conductor ampacity, and termination temperature ratings. Let's examine each of these aspects in detail. Firstly, conduit fill refers to the percentage of the conduit's cross-sectional area occupied by conductors. The NEC specifies maximum fill percentages to prevent overheating and ensure ease of conductor installation and removal. For underground installations using PVC conduit, Table C, 1b of the NEC 2020 specifies a maximum conduit fill of 53%. In this scenario, 3 sets of 500 MCM copper conductors are installed in separate PVC conduits. To determine the total conduit fill, we need to consider the fill percentage for each individual conduit. Since each conduit contains one set of 500 MCM conductors, the fill percentage for each conduit is 53%. Therefore, the total conduit fill for all 3 conduits is 3 multiplied by 53%, which equals 159%. This exceeds the maximum allowed conduit fill of 53%, indicating a non-compliance issue. Secondly, ampacity refers to the current carrying capacity of a conductor, expressed in amps. The NEC specifies ampacity ratings for different conductor sizes, insulation types, and installation conditions. Table 310.16 of the NEC 2020 provides ampacity values for conductors based on these factors. For 500 MCM copper conductors installed in PVC conduit, the ampacity is 1250 amps. This means that each 500 MCM conductor can safely carry up to 1250 amps of current. In this case, the main service is rated for 1200 amps. Since the ampacity of the 500 MCM conductors, which is 1250 amps, is greater than the service rating of 1200 amps, the conductor ampacity is acceptable. Thirdly, terminations refer to the points where conductors are connected to equipment such as circuit breakers, transformers, or distribution panels. The NEC requires that terminations be properly rated for the conductor temperature and the maximum allowable temperature of the termination point. This is to prevent overheating and ensure reliable electrical connections. The lugs used for terminating the 500 MCM copper conductors must be rated for a temperature of 75 degrees Celsius. This means that the lugs can safely operate at temperatures up to 75 degrees Celsius without degradation or failure. Whether this is acceptable depends on whether the main CT cabinet provides adequate ventilation to keep the conductors and lugs below 75 degrees Celsius. If the ventilation is sufficient, the termination temperature rating is acceptable. In summary, while the conductor ampacity and lug ratings meet the NEC requirements, the conduit fill exceeds the maximum allowed. To bring the installation into compliance with the NEC, one of the following options must be implemented. 1. Increase the conduit size. This involves replacing the existing PVC conduits with larger ones that can accommodate the 3 sets of 500 MCM copper conductors while maintaining a conduit fill of 53% or less. The specific conduit size required will depend on the dimensions of the conductors and the conduit's internal diameter. 2. Replace the wire with 600 MCM copper conductors. This involves replacing the existing 500 MCM copper conductors with 600 MCM copper conductors. 600 MCM conductors have a higher ampacity than 500 MCM conductors, which provides an additional safety margin. They also have a smaller cross-sectional area, which reduces the conduit fill. Replacing the 500 MCM conductors with 600 MCM conductors will reduce the conduit fill to 45%. Which is within the allowable limit. 3. Reduce the main service amperage. This involves reducing the rating of the main service from 1200 amps to 1000 amps. This would match the ampacity of the 500 MCM conductors, which is 1250 amps. However, reducing the service amperage may not be feasible if the load requirements of the building or facility exceed 1000 amps. Choosing the most appropriate solution depends on various factors, including the existing infrastructure, load requirements, and cost considerations. Consulting with a qualified electrical engineer or contractor is recommended to determine the optimal solution for the specific installation. It's important to note that the NEC is a comprehensive set of regulations that is regularly updated to reflect advancements in electrical technology and safety practices. Staying informed about the latest NEC requirements is crucial for ensuring safe and compliant electrical installations. Always refer to the most recent edition of the NEC and consult with qualified professionals for specific guidance on electrical projects. In conclusion, the installation of a 1200 amp main service underground using 500 MCM copper conductors and PVC conduit requires careful consideration of NEC requirements for conduit fill, ampacity, and termination temperatures. While the conductor ampacity and lug ratings may meet the code, exceeding the maximum allowed conduit fill is a violation that must be addressed to ensure safety and compliance. By implementing one of the recommended solutions, such as increasing the conduit size, replacing the conductors, or reducing the service amperage, the installation can be brought into full compliance with the NEC. This will help to ensure the safe and reliable operation of the electrical system for years to come. Always prioritize safety and compliance when working with electrical installations, and consult with qualified professionals for any questions or concerns.